Hi, hello, namaste. Welcome to Parthos tutorial. I'm Madhavi, and as you know, in this Parthos tutorial channel, I'm explaining about the physics, which means topics in the physics, so which are related to IIT and which are non-IIT, non-JEE syllabus also, which I'm explaining. So now I'm proceeding this topic with the reflection of light in a curved surface, which is there in the 10th class first lesson, physical science first lesson. So in the up to now, as of now, I have explained about the 7 parts, and I have explained the topics which are about the 7 parts. Okay. So now let me explain with the another part which are about the problematic questions. As with this, some are the mostly 90% syllabus is completed. So based on that completed syllabus only, let me explain the problems. 2 problems I will explain. I hope with these 2 problems you will get 100% clarity, and you can also easily solve the problems, what type of problems if they are giving in the examiner. Okay, so you can solve. So we'll see, without making late, let's start the problem solving, or else the problematic question solutions. Am I clear? So before that, let me talk something about the previous video, which is about the I have explained about the image formation. Thereafter, sign conventions. Conventions are most important. If they are giving sign convention as a direct answer, they may also give you, or else this sign convention will also useful to you in the problem solving. So sign conventions are mostly important. Don't skip the sign convention for a choice. Okay, you compulsory have to read. So now in this sign convention, after that I have explained about the magnification and mirror formula, and there are 2 formulas: r equal to 2f, 1 by f equal to 1 by v plus 1 by u, and finally magnification formula. Totally 3 formulas in this lesson. I have explained the enter 3 formulas. So now the next one about the I have told you in the previous video, we'll see some more extra problems in this video. So if you didn't watch the previous video, because if you understand those only, you will get clarity about this video now. So if you didn't watch that video, I am sharing the previous video link or channel link in the description box. You can please go through and watch the video. And without making late, let's start the topic. Okay, so we'll see. So I will be give you 2 different types of problems to you. Whether mostly I'll try to give 3. Okay, in the concave, two problems. From convex, 1 problem. Okay, we'll see all the three problems in this session, or else I will try to explain 1 problem in 2 problems in part 1, and in this part, and 1 more problem in the next part. Am I clear? So whatever, let me try. So now this first question, I am telling, I am keeping an object at 2 centimeters in front of a concave mirror. I hope this thing which I already gave you in the previous video to solve. So let me solve by myself. Okay, focal length is a 5 centimeter. So we are keeping the object at 2 centimeter distance in front of a concave mirror, which has a focal length of 2 centimeters, which means in the examiner directly giving us u value and f value. Okay, so now find out the image distance and write the characteristic of image. Okay, so this is the first question. This is the first question, and characteristic of image, and find the magnification also. Characteristic of image means nothing but we have to find the magnification. So let me write, this is the first question, and second question is, okay, so let me tell, after completion of this we'll see. Okay, so in this problem, so now first apply sign convention. Applying sign convention, please write this one, don't forget to write. Many of you are forgetting do the sign convention before solving the problem. So this is an important one. You should have to apply the sign convention before solving only. U is equal to minus 2 centimeters and f is equal to minus 5 centimeters. Okay, now with using the mirror formula, 1 by f is equal to 1 by u plus 1 by v. 1 by minus 5 is equal to 1 by v, we don't know, plus 1 by minus 2. So minus 1 by 5 is equal to 1 by v minus 1 by 2. So this minus 1 by 2 I am taking this side. Minus 1 by 5 is equal to plus 1 by 2. If I am taking this side, it will become plus. So 1 by v. So now LCM for these two. Okay. Sorry for the distraction. So now see. So minus 1 by if I am taking this side, it will become minus 2. So the LCM for these two will become 10. Okay, 5 2s are 10. So minus 2. So in this LCM, in this 5 table, it will come into 2 into minus 1 minus 2. In this LCM in 2, it will come in 5. 5 into plus 1. Above 1 is 5. So now it will become minus 2 plus 5 by 10, which is equal to 1 by V. Which means 3 by 10 is equal to 1 by V. So if we want V value, so it will become 10 by 3. Am I right? So 3.3 centimeters. So see, if you observe, we are getting positive value. So V is we are getting positive, which means image is not forming in opposite direction to the incident ray. We'll see. By diagrammatically also it will be proved. Okay, which is C and which is F. So what they are telling, F is 5 centimeters. F is 5 means radius of curvature will be, it is 10 and this is 5. And what I am telling U is there at the 2 centimeters, which means object is there at here. So you can draw the image formation diagrams for these two. So one is I am drawing this one. Another one is, okay, if the incident ray passes through the center of curvature. So if the incident ray passes through the center of curvature, it will be reflected along with the same line. So this will be move like that. If I am extending backwards, okay. So here an virtual image is forming. This is the case 6, which I told you, very important. If you see here, F focal length we are measuring in opposite direction to incident ray of this object is there. Incident ray of this object will be in that direction. But image, the distance of this object we are measuring in opposite direction now. So U is negative only, obviously. And focal length is also negative. Fine. And radius of curvature will also be negative. Why? Because if it is forming in a opposite direction to the incident ray only, we are measuring. Okay. So then the image distance will be, we are measuring in a same direction of incident ray. That's the reason we are getting the V value positive. Now you got clarity about this one. So we are measuring the image distance in the same direction of the incident ray. That's the reason we are getting positive value. So now, if we are getting V is positive value, we already know this is the virtual image, right? So now, if we are not having an idea about the image formation, we only know about the problematic question, how to solve the solution. By the solution only, if you want to know about the details about this characteristic of the image, then you just have to go through the magnification. Okay, you have to go through the magnification. Then here I will write magnification will equal to M is equal to minus V by U, and M is minus, already V value positive only, so that's the reason instead of writing 3.3 I am writing 10 by 3. Okay, 10 by 3 by, what is the U value? Minus 2. Can I cancel minus and minus? So M is equal to 10 by 3. This 2 by 1 I am taking, this will become 2 by 5. 2 1s are 2 5s are. So M is a 5 by 3, which means 3 1s are and 3 6 are. Again it will be 6 bar. So M is equal to 1.6. So which is magnification greater than 1. Of course, yes or no? Magnification is 1.6 is a greater than 1. And magnification is a positive. If the magnification is a positive, that is compulsory. See which type of image will be? Virtual image only. That is virtual image. Virtual means it is compulsory erected one. Okay. If M is positive, that is virtual and erected. And if M is greater than 1, of course it is larger than the object, right? So M is greater than 1. Am I clear? Or else, if M is negative, so we'll see one more problem. In that problem, we will get compulsory M is negative. If M is negative, that is compulsory a real image. And based on this size, we can say greater than 1, or if it is greater than 1, larger. Less than 1, smaller size image. If it is equal to 1 magnification, same size image. If it is positive, compulsory, that is a virtual image. Yes, if it is negative, compulsory, that is a real image. Am I clear? That's all about this problem. And let me explain one more problem related to this. Okay, one more problem related to this. Okay, now, so now see. So now, second problem. So now I am telling, so I am keeping an object 8 centimeters and focal length is 4 centimeters of a concave mirror. Okay, so we are keeping an object at a distance of 8 centimeters in front of a concave mirror. They will give questions like that only, but I am not writing here, simply I am writing the values. So if we are keeping an object in front of a concave mirror at a distance of 8 centimeters of which has a focal length of 4 centimeters. If it has a focal length 4 centimeters, what is R will become 8 only, na? So R is 8 means U is also 8. So we can predict where the object is exactly there at the center. Where the object is exactly there at the center. If we already know, if you know about the if you know about the image formation, if you are keeping an object at center of curvature, image will also be formed at the center of curvature with the same size. Yes, you know. So let me write that one. So based on this problem, we have to get the values. Compulsory we have to get now. So now we are keeping an object here. So now second one. See. So where the object, there at the same point, image will be formed with the same size and same height, but real and inverted. Real image only, na? So this is the case actually. For this case, we have to, by mathematically, by calculation, whether we will get the same value or not, we will see. Here actually properties already we know. Real and inverted, and also which is same size, which means magnification we have to get 1. We'll see whether we will be get that 1 or not. Okay, now let me try with that. So first we have to apply the sign convention. U is equal to minus 8 centimeters and F is equal to minus 4 centimeters. So now 1 by F is equal to 1 by V plus 1 by U. Okay, 1 by minus 4 is equal to 1 by V we don't know, plus 1 by minus 8. So now minus 1 by 4, this minus 1 by 8 I am taking this side, it will become plus 1 by 8, 1 by V. So for LCM for 4 and 8 will become 2 2s are 2 4s are and 2 2s are 2 2 1s are 2 2s are 4 4 2s are 8 something 4 8 minus 2 plus 1, because the in 4 table 8 will come 2 into above minus 1, like that only. So yes, and 1 by V, 1 by V. So now minus 1 by 8. So V is equal to, actually what we have to know, only 8. So that is also I am reversing ulta. So V is equal to minus 8. We got now. What is U? Minus 8. What is V? Minus 8. Exactly, one is clear, right? In which distance the U will be there, in the same distance V will be there. One is satisfied, right? So now we will see magnification. Magnification minus V by U. So what is V value? Minus of minus 8. What is U value? Minus 8. Minus minus will be cancelled, na? Will be cancelled. So 8 ones are 8 ones are. So M is equal to what? M is equal to minus 1. So I already said you, if the magnification is equal to 1, same size image will form. Satisfied, right? Same size image will form. But if magnification is negative, I said you real image. If M is negative, that is compulsory a real image, real and inverted image. Now satisfied, na? So now this see M is equal to 1, same size of course. Real and inverted only, not virtual. This is the case. Am I clear? That's all about the another problem. And finally for a concave mirror, how the sign conventions will be changed mostly. Okay, let me tell you short analysis. If you know, if you want, you just have to take, you have to capture this one, you just have to take. Okay. So now, finally, let me give you a short briefing about this. Okay, so if magnification sign convention for concave mirror, finally what we can understand, mostly from case 1 to 5, from the where from infinity to at focus, all the u value, object distance will be negative only always, and image distance will also be always negative. Simply let me write. For concave mirror, u is always negative, and v is also negative for which case? Up to case 1 to case 5. And what is focal length, which is also always negative? Focal length, object distance, radius of curvature will always be negative. Only the v will be changed based on the only in the last case, that to be. In all cases it will also be same. And r is also negative. Okay, from case 1 to 5. In the last case, in the concave mirror, case 6 is there na, which is form virtual image. In that case, even that case also u is negative, and but v is positive there. Am I clear? Because the v value we are measuring in a same direction of incident ray. I already explained to you. F is also again negative. Only v value will be changed, and r will also be negative. So mostly you can understand, for a concave mirror, u, f, r, these three factors always negative, but v will be changed based on the case. From 1 to 5 case, it will always negative. This will also be negative. Only in the last case, when we are keeping an object between focus to pole, at that time v will be positive. That's it. Remaining all will be similar. You just have to remember this one while you are solving the problems. Okay, na? This is the case. And let me explain. That's all about the today's part. And in the next video, we have to solve some more problem based on the convex mirror. And in the convex mirror, how can we predict the characteristic of an image in the same this manner only. So we'll see. So for the convex mirror, we already know you can easily predict the image is always a virtual. Yes, the magnification will always be a positive. So we'll see by calculation also we have to prove that na. So let me prove that in the next video. Until that time, please keep watching the video, and if this video is useful to you for your exam purpose, please like the video and share the video and subscribe the channel. You just have to click the bell icon. You may get the notifications of my first videos to reach you. And that's all, and thank you for watching the video, and thank you so much. If you have any doubts about this topic, because I am covering only the important topics in this lesson. So mostly in the next video I will explain about the convex mirror problem, and thereafter the last with the solar cooker. With that I will end this lesson. But even if you have any doubts in this lesson, to explain anything, you just have to comment below, and I will try to respond. I will try to make a video, and I will try to give a clarity for your doubt. Am I clear? Thank you so much.